Good and welcome back to our video 3 on the topic permutation and combination. We already saw in the first video that we have three letters A, B, C and D, that the number of ways you can rearrange these four letters, where the order, of course, is important, is by making that our box with 4. And we said to choose a letter to begin your combination, it can be, or your permutation or your arrangements, we should be saying here A, B, C, and D. So there are 4 possibilities here. So here we are trying to talk about arrangements, please. So after that we get 3, 2, and 1. That is in a situation where the arrangements you want to make always have 4 letters. It could also be that you want only a subset. Maybe a teacher is teaching a classroom and you want students to come and help with a piece of work or something, and you're not interested in where it's coming, so you just want 5 out of your class. Then you have to think about it. How do you get 5 students out there? Or what are the possible numbers of 5 students that you would get out of the class to do that job? But if I'm going to take only 2, let's now look at example. If I want to take only 2 letters at a time, let's start again with A. We already saw this is 24. If I take A, then I can get several possibilities. A can go with B, A can go with C, A can go with D. So there are 3 of them. If I take B, B can go with A, B can go with C, B can go with D. B can not go with itself because, of course, we say these letters are not repeated. We say without repetition. So once you take a letter, it does not exist anymore. We will see more of that later. If I take C, this is C with A, C with B, C with D. If I take D, D with A, D with B, D with C. If you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 of them. If I also use my idea, the one we mentioned, for this second case, we want to choose only 2 from this. We want to arrange 2. Notice that I have AB, I also have BA. I have AC, I also have CA. So those ones are new. They are counted because the order here is really important. AB is not the same as BA for this setting. And that's what we will later on describe as permutation. So if I have to take only 2 letters out of these 4, then means the first place here can be occupied by 4. So I can start with any of them, A, B, C, or D. And once I've chosen one to start, then there are 3 others to choose from. And here I see this is 4 times 3. And that is 12. So the idea is, how do I express this as something that is in this form? Actually, we see that this, this can be seen as 24 divided by 2. So if I take this, I divide by 2. So which means if I want to look for the number of arrangements that I can make with 2 letters at a time from 4 letters, I would first say, how many 4 letters are there that you can make? And then I say, but from the 4 letters, of course, you can reduce them by this. So we would write in this form, but we knew that this was called 4 factorial. How do I express this now in terms of factorial notation? Actually, this is going to be 4 factorial divided by 4 minus 2 factorial. So this is 12. Where 4 factorial is all the possible elements of the 4 letters taken 4 at a time. And below here is, 4 minus the number of letters you are choosing at a time to do that. And in that case, we had 4 and we had to reduce 2. 2, we have to take 2 at a time. That means if we are taking 3 at a time here, then for 3, we'll have something like this. The first place will be 3, 2. And if we arrange this well, it's going to be 4 times 3 is 12, times that is 24. So in this case, we are going to get 4 factorial divided by 4 minus 3 factorial. In general, then, if we have n number of letters and we have to choose only r of them where the order is important, then we'll write it in general as n factorial divided by n minus r factorial. So that's the idea here, where the P is for permutation. So we say this is n permutation r. how many arrangements are there of choosing R things from n of them, where the order is important. We call that permutation. As you will see here, usually in questions that come, the students are always confused when do I use permutation. If the questions have keywords like arrange, rank, ways, schedule, lineup of people, digits, letters, colors, etc., and you see that the order matters, then you should be talking about permutation. Of course, we are going to see 2 or 3 other videos where we solve real questions, exam questions. There could be SAT, there could be GCE, there could be WAEC, different type of examinations for secondary school kids. So if this is the case, we would move on to combination. What's the difference between the permutation and combination? That's what I'll bring now here. But at least you already know n permutation R is defined as n factorial, n minus R factorial. I already gave you some examples here. If we have 4 and we have to choose only 2 from them, then that's going to be 4 factorial divided by 4 minus 2 factorial, and we already saw that. For combination, it has still the idea of arranging stuff, but this time our idea is groups. You will see terms like selection, choose, subjects, clothes, menu. We're talking about groups of things. How to pick out these groups? The example of students from the class. You want 5 students. You don't care who comes out first, who comes out second. You're just interested to see 5 students, group of 5. That idea will be something like combination. But I will make a small illustration. So we go back to our A, B, and C. We already saw that this had A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. There were 6 possible arrangements. And we said these are 6 permutations of the A, B, and C. Because here, the order matters. So for permutation, we have 6 of them. Combination, the order doesn't matter. A, B, C, A, C, B, B, A, C is the same thing to combination. So we have only one combination. The idea will be, how then do we do this? In order to relate permutations and combinations, we always try to say, if you have to do a combination, first do the permutation. After you have done the permutation, check the ones that have exactly the same letters and drop them. Uncount them. For example, if I have ABC, I check this. ACB, BAC, all the 6 they do have. So actually there's only one of them. So it's actually 6 divided by 6 here. Only one of them. Because 6 is repeated. The same thing is done 6 times. Because you have a combination, the other is not important. Examples of things that require order and be important are like prizes. First prize, second prize, third prize. That's important. There is an order. First prize is not the same like the second prize. But if I just need 3 people to do something, I don't care who comes out. So if it is student A that comes out first, or student B, or student C, that doesn't matter. Then I need 3 students. Then we talk about combination. I will get to the details of it in our next video. See you soon.